Good morning, everyone. Go ahead and give it a couple minutes or seconds to make sure everyone is transferred over from the waiting room. Great, well, I think that's everyone from the waiting room, so we'll go ahead and get started. Welcome, everybody. This is day 2 of the Solar Decathlon Semifinal Competition event, Design Challenge presentations in the Multifamily Division. For those of you who are new today, which I assume is most of you, my name is Amy Labar. I am a research engineer in commercial buildings at NREL, and I will be facilitating the session today. And I am joined by my colleague, Brittany Speedles, who is a research engineer in accelerated decision and deployment support. Each and every one of our teams has worked hard up to this point on their design projects and will present their work to industry experts. Based on the presentations today, only 10 finalists will advance to compete at the final competition event in April. We will conclude the day with important announcements, including the announcement of our 2023 Design Challenge finalists. Before we begin, a few housekeeping items. Can you go 2 slides forward, Brittany? So just a reminder to please keep your cell phones on silent during the presentations and be courteous to each team as they present by staying on mute and with your camera off unless you are presenting. Each presentation will be 8 minutes with 5 minutes of Q&A. We will be strict with maintaining the 8 minutes for each team to ensure everyone gets equal time to present. Brittany will be sharing a 2-minute warning and time's up background on their camera, so keep an eye out for those and please stick to the allotted time. If you have any technical difficulties, please chat Brittany in the chat box for assistance. Next slide. All right, I would now like to introduce our esteemed panel of industry expert jurors today. Sarah Hong is on the affordable housing team at Group 14 Engineering, where she leads energy and sustainability services for multifamily projects pursuing green building certifications. She specializes in housing tax credit projects as well as market rate projects with ESG and sustainability goals. She has a strong interest in cost-effective and highly efficient all-electric designs for residential buildings. She is an NGBS Green Verifier and Energy Star Rater with experience in mechanical system commissioning, embodied energy analyses, and resilient building design construction. So welcome, Sarah. We also have Luz Toro joining us, who is an architect licensed in Colombia by CPNAA and an international AIA associate. She has 10 years of experience in design, project management, and leadership, sustainable architecture, Colombian vernacular architecture, and passive design. Toro has worked on government-funded projects, private residences, offices, schools, and urban spaces in the public and private sectors. In her current position as manager of resilience and climate adaptation, she develops tools and resources to help architects and future architects understand the challenges and advantages of including resilience and climate adaptation solutions in their projects. So thank you, Luz and Sarah, for joining us today. We are very happy to have you.
Really excited to be here.
So we have a couple minutes before the presentations kick off. So I wanted to give an opportunity for the jurors to share some of their wisdom about life after graduation from university. So a question for the 2 of you, what advice do you have for students graduating from college and beginning their careers?
I can start. Let's see. Well, not sure if you all were here yesterday, but my background is in chemistry, and I used to teach high school chemistry in the Bay Area. And I really enjoyed teaching, but also wanted to pursue a career in buildings and mitigating climate change. So I went back to school for architectural engineering and joined the Solar Decathlon team. And as you all are probably aware, it can be very overwhelming. There's a lot of stuff that you need to put into your design that you're not familiar with, but it's a great learning experience. And honestly, one of the most valuable things you're going to get out of this are the connections that you make while you're collaborating with professors and professionals and other industry leaders. Solar Decathlon is what got me my first engineering job. So I said this yesterday, but I really do think it's important to nurture those relationships use the resources you have around you to make connections to people in industry, and talk about solar decathlon on your job interviews. The work you've done here is really impressive and already puts you at the top of the pool.
Thanks, Sarah. Luz, any words of wisdom?
Well, I don't know if it's wisdom, but and something that I will tell you is that you have to think outside of your box. Like, it's very important that in your career you don't focus so much in the technical aspects, but also you open your mind to activism, to advocacy. I think it's very important that you see other ramifications in your career, other paths that you can take. If you are, for example, just focused in design, you can do a little bit more of administration tasks that is going to lead you to sustainability, something like that. So, and I think that's very important, just because we have so many designers that just get focused on the design of the building, and there are so much more that you can do.
Great. That's excellent advice from both of you. And I would second that as well. The communication piece and making sure you really take advantage of your connections and nurture those relationships, I've found to be super important. And then some of the roles that I'm actually in at NREL, I never really thought I would see myself in, but I had the opportunity to step outside of my comfort zone, and it's paid off, and I'm really enjoying the work I'm doing now. So excellent advice. So we have about 3 minutes until the presentation time slot. I've been asked by the Solar Decathlon organizers to maybe get a group photo before we get started. So for all of you online, if you wouldn't mind turning on your cameras, and I'll take a group screenshot. It's so nice to see all your faces too. All right, great. Okay, I'll count to 3 here. 1, 2, 3. All right, got it. That was my first virtual group photo, so hopefully it turned out. All right, so we have 2 minutes or so. So if UCLA, you're the first team, if you want to start sharing your slides, and maybe do an audio check to make sure that we can hear everyone.
Excuse me, this is a video check. I'm sorry, this is an audio check.
Yes,
I hope you guys can hear me all right.
Yep, sound great, Laura.
How about me coming through?
Yep.
Good.
And
Yeah.
same here. You guys can hear me okay?
Yep, loud and clear.
Perfect.
Just Sterling here. Hopefully you can hear me as well.
Yep, sound great. Awesome. All right. Give it another 30 seconds or so, just so we start right on time. I'll let you know when you can start. All right, looks like we're at 10:10 Eastern time, so whenever you're ready, take it away.
Thank you very much. Hello everyone, we're UCLA Brewing Builders, and we are here to present our design proposal of Hollenbeck Village, located in the neighborhood of Boyle Heights, East Los Angeles. My name is Kenny, and here with me today are 4 other members in the team. We have Laura and Connor from the architecture, and Sterling and Luca from the engineering team. We'll begin our presentation with introduction of our design narratives, what drives our design, and transition into some of the site specifics, and then conclude with aspects of the design that reflect the criteria outlined by the competition.
So some of the design goals that we focused on for this project are shown here. We want this multifamily building to be affordable and bring together members of the community with attractive spaces. We want to achieve a net zero with on-site renewable generation while also electrifying our technical systems. A modular approach gives a simplified variability to the types of families that can live at Hollenbeck Village, and incorporating a passive design reduces energy use while taking advantage of the temperate Los Angeles climate.
In September of 2022, the government of California signed a B2295, or the Education Workforce Housing Assembly Bill, which aims to build below market housing for teachers and other school employees on public school land. Thus, we chose an empty lot on school grounds of Hollenbeck Middle School to develop our project. The lot is also located south of 2 other high schools and a continuation school, thus allowing our proposal to serve a larger pool of students, of teachers and school employees. Guiding our design strategies in both the realm of architecture and engineering are the 2022 California Building Energy Efficiency Standards. We aimed, however, not to use these as simply guides, but surpass them throughout our design.
So I want to take a moment to talk about our site analysis. We're located in a Mediterranean climate, so year-round we have a pretty consistent temperature. You can think of us as having a dry season and a wet season with a low yearly rainfall. We have an average humidity of about 60%. On the right here through this diagram, you can see our prevailing winds are coming from the northeast. And I want to highlight that we've taken the opportunity to implement drought-tolerant indigenous plantings on the north side of the site to create a degree of separation between the living units and the nearby school. Next, we're going to dive into some deeper details about our design concepts, starting with market analysis.
So after conducting a market analysis, we concluded that Boyle Heights is a predominantly low-income renter Latino neighborhood located east of downtown Los Angeles. Like most underprivileged neighborhoods in Los Angeles, Boyle Heights suffers from a chronic lack of affordable housing and access to green spaces. This is one of the reasons why housing affordability was a driving element in our design process.
So what you're seeing here is a comprehensive overview of many of our design concepts. We basically have 3 different types of modules that we're implementing. We have social modules, which can include things like food pantries and gyms. We have utility modules, which house water recovery units and energy storage systems. And we also have dwelling modules as well that come in 3 various sizes to accommodate different living situations. Everything is ordered on a pretty strict ordering system. And it can be rapidly assembled with modular fabrication offsite, which lowers construction costs and minimizes disruptions to the nearby school.
Each of the 3 modules has 2 main components: a breezeway for passive cooling, which is consequential of 2 opposing large windows, and a utility corridor. Through this partial floor plan, we hope to highlight the way the modules can be combined, mirrored, and rotated for the optimization of shared plumbing walls.
So as Connor discussed, we oriented our buildings to maximize the passive energy gains. So we oriented towards the prevailing winds and put space between our modules and chose our window positions to enhance the cross ventilation, reducing cooling loads in the summer and the associated energy costs. The east to west modular orientation also takes advantage of natural lighting and passive heating in the cooler months. We specified Energy Star certified appliances to conserve water and energy and a decentralized HVAC system, giving occupants control over their own indoor temperatures. The modern open plan floor plan of these creates a luxurious feel and integrates the indoor and outdoor with each of the units. Our primary building envelope material we chose was a 5-ply cross-laminated timber. And obviously on each side of that, we chose that for its sustainability and for its insulative properties. And obviously on either side of that, a number of other layers of waterproofing and insulation to ensure a safe and secure building envelope that would remain relatively insulated throughout the year. The primary structure is structural steel framework, which each of these modules sits into, gives some flexibility in the orientation of the modules and how they're set up within the framework. And we chose a variable refrigerant flow HVAC system that is able to serve multiple units. And this is for the ease of access for maintenance down the line.
So as Luca mentioned, there's a lot of flexibility in how we orient our modules. And this allows for us to position them in a way where upper units are shading the lower units during the summertime, but allowing solar heat gain in the winter when the sun is lower on the horizon. We have a plan here to implement 40,000 square feet of drought-tolerant indigenous plants to support local pollinators and also increase biophilia. Here on this diagram as well, you can see we are collecting gray water through our sinks and showers, and we're collecting site water through our photovoltaics as well.
So as you can see here, most of our embodied carbon came from our materials. These are largely down to the concrete, which is difficult to replace necessarily in a foundation, but there are some interesting innovations in carbon capture concrete, which we considered. And the other one, of course, is steel, which is pretty carbon intensive. But there was an open conversation about shifting that structural material into timber.
Using PV watts, we calculated the annual renewable energy production for solar panel configuration that fully covers the rooftops of each block in the complex. Based on our preliminary open studio model, we have an estimated site EUI of just under 16 kBTUs per feet squared. This does suggest that for the total energy consumption of the building, we are achieving a net zero design, but it is worth mentioning that we're still working to introduce key technical components into our energy model. This brings us to some of our goals ahead of the final submission. We want to create a more detailed energy model that not only incorporates our designed HVAC systems, but we also want to explore additional energy efficiency measures that optimize the building operations. We're interested in utilizing battery storage in conjunction with on-site solar power, and we're still exploring the cost benefit and feasibility of other storage mechanisms outside of the conventional lithium-ion battery. In this context, battery storage can not only add resiliency to the community at Hollenbeck Village, but also to the nearby education facilities that may be relied on in the face of emergency or natural disaster. We've made design decisions for the main mechanical, electrical, and plumbing equipment and fixtures. And going forward, we want to better understand how those utilities are distributed and how the different trades work with one another. With some of this additional detail, we want to revisit our life cycle assessment to include a more refined list of building components and materials, and also discuss alternatives to those that contain high embodied carbon. Lastly, we plan to continue iterating on the design as a whole and search for more inspiration within the team and hopefully industry sponsors in the future. And with that, thank you for your time, and we're open to any comments or questions that you have now.
Great. Thank you for your presentation. I'll open it up to our two jurors to ask some questions.
Thank you for that. This project looks great. Your design goals are spot on. The project addresses a lot of critical issues that we're seeing today with affordable housing, walkability, it's community centered. I think that's great. It's also the rainwater capture is really important in a place like LA. The VRF system is also, I think, very appropriate for this climate. I have a couple of questions. One, I noticed the utility costs, even though you are in like a very mild climate, you have a great system, the utility costs did seem a little bit high. Did you do like an analysis of that? Is most of that coming from like plug loads or?
Yeah, so the majority of that estimation was just based on the yearly energy consumption of some of the equipment itself. We still haven't within our energy model, we haven't had the opportunity to introduce utility estimation costs from the area because we're still working on gathering that information, but that is something that we want to look to minimize with sort of these energy efficiency measures that we are implementing.
Gotcha. Thanks. My second question is, were any climate risks considered in your design, either with the envelope or with the mechanical systems, particularly the risk of wildfire pollutants in the area and the impact on indoor air quality?
So the main risks that we were focusing on, at least initially, was the fact that the California or the LA area lies pretty close to some large fault lines. Our structural system is designed to resist any severe earthquakes that may occur in the area, and with sort of the building envelope, we do definitely want to explore how we can also apply some type of fire rating to important systems, maybe on the ground floor, and also providing safe ways for our building occupants to get out of the area if they need to in time of fire. But yeah, that is definitely something that we also want to look at further.
We do also have that large grey water repository, which we have access to in the event of fires. So.
This is a great project. I really like that you integrated passive strategies into the design, because the climate, I think, will have an opportunity for that. I was wondering about the operating windows that it will require a human behavior. What are your plans and strategies for these passive elements that always require a human behavior?
That's a good question. There is always that trade-off of having operable windows that do require some amount of energy consumption to be I guess electromechanical versus someone just opening those up themselves. We haven't looked into the details yet of sort of that trade-off of how much energy those might consume, but at least in our mind now, if one of the occupants did want to utilize the nice outdoor climate of Los Angeles, right now at least we were thinking that they would just open those windows, but considering accessibility and making sure that is something that can be utilized by all different people, we want to make sure that we are catering to specific needs where operable windows would be more beneficial.
That being said, a big concept that we are kind of playing with this project is sort of the idea of like architectural porosity. So even if all of the windows on the units are closed, the airflow from the north side of the site would still be able to flow through the building uninterrupted, just due to the spacing between the levels of the floor. So that was sort of one of our strategies when approaching the passive cooling systems here.
Great, thank you for the clarification. And the other question, have you made the math about how effective will be the windows for cooling, the size of the windows?
Sorry, would you mind repeating the question?
Sure. Have you made the math in how effective will be the size of your windows as a passive strategy?
Oh, I see. So we haven't we did factor in the size of the windows and just their internal factor into our energy load calculations, but we haven't yet explored how that would change if we were to alter the size of the windows. So that's another great point for us to go back and look at going forward. So thank you.
All right, I'm gonna have to cut Q&A off there, but thank you, UCLA, again for your great presentation.
Thank you very much.
Thank you.
Thank you.
All right, Illinois Institute of Technology, you're up next. You're welcome to start sharing your slides and do an audio check to make sure we can hear you.
Hello, this is an audio check.
Yep, sounds
Wonderful.
great. All right, and we are right at 10:25 Eastern, so whenever you're ready, take it away.
Wonderful. Okay. Good morning, everyone. My name is Sarah Kay, and Severin and I will be presenting on behalf of the 9-student team from the Illinois Institute of Technology. Today, we will be presenting our project, The Growing Haven. Here's a quick overview of what we will be presenting, including community, site, architecture, and engineering. Our project is located in South Chicago on the 61st Street within the Woodlawn neighborhood. And according to the Biden administration's Justice Initiative, Woodlawn is considered to be disadvantaged. Therefore, our team's goal is to address this disadvantage by providing residents with the opportunity to own homes in an effort to build intergenerational wealth. Our team's community partner is Sunshine Gospel Ministries, which is an organization located in Woodlawn that prioritizes home ownership to promote equity. By working with them, we are creating a mixed-use building that not only provides the local residents the opportunity to own their own home, but also generate profit in the commercial spaces that will lower the cost of home ownership. In addition to home ownership, our project also develops a typology for filling vacant lots on commercial and residential streets. At the beginning of the design process, we learned that our community stakeholders really want residential developments to feel inviting and familiar within the fabric of the neighborhood. So we studied the local architecture and found that most of the homes have a brick finish, and a common element is a bay window. In its current state, our site is vacant, and it is surrounded by a handful of vacant lots, and these vacancies interrupt residential and commercial streets. Knowing this, our design needs to reintegrate our site and surrounding vacant lots into the fabric of the neighborhood. Therefore, our proposal acts as a catalyst in reviving the 61st Street commercial corridor through the creation of pedestrian-friendly public spaces. As can be seen in the massing diagram, by pushing the residential floors away from the street, more space can be allocated for commercial program that activates the street. As can be seen on the ground floor plan, the courtyard invites the public into the boutiques and the cafe. And these commercial spaces also generate profit for the building, which is used to help lower the costs and make it more affordable for residents that own homes within the building. The residential floors feature two different types of units, owned and rented. The 3-bedroom units and 2-bedroom units are owned, while the 1-bedroom units are rented. We designed these so that the adjacent units can be merged into a 4-bedroom home if owners wish to expand. Here is a view of our commercial entrances, and as you can see, a majority of the material is brick, and we've integrated this idea of bay windows into the residential units. This is an interior view of a residential unit, which shows the natural light that the space would get, and also an example of how the space can be laid out. Before we get into the energy analysis, we wanted to highlight the passive strategies that our building implements. Because we are located in a heating-dominated zone, our building is oriented along the east-west axis to maximize solar exposure and take advantage of natural daylighting. To minimize heat loss, our envelope is airtight, and additionally, each residential unit has operable windows and fans that can be used for thermal comfort.
Awesome. Thank you very much, Sarah. My name is Severin. I'm going to be sharing our energy and engineering side of our project. So this aspect of our project, the annual energy, we thought we'd start here and then show you how we got here. After incorporating passive and active strategies, as mentioned in the previous slide, our EUI is 16.1 kBTU per square foot per year. For the majority of the year, lighting and equipment demands exceed the building's heating and cooling demands, and we're confident that further analysis can bring those numbers down as well. The energy generated from the PV system is more than the energy consumed for 9 months, keeping the building off the grid for most of the year. The overall annual energy generated from the PV exceeds the annual energy consumed by the building, bringing us to a net zero building. Going through our envelope design, to accomplish our energy and affordability goals, we recognize that sacrifice needed to be made somewhere. By accepting a lower LCA and avoiding a thermally broken wooden frame system, we opted for an insulated concrete form structure with low impact carbon concrete. This allows for an affordable construction method, high quality insulated enclosure, and fewer zones where air leakage problems may occur. For our residential and HVAC plumbing, the spaces are conditioned by roof mounted VRF systems and a dedicated outdoor air unit. The system is affordable and minimizes losses through short refrigerant lines. Additionally, heat pump hot water heaters are stored at each floor lobby as to minimize sound and transmission and maximize space use. For our commercial spaces, we primarily require our MEP systems to be running on a 12/7 schedule. Given limited use and individual space needs, controllable wall-mounted ductless mini split air conditioners are provided throughout so that individual zones can be accommodated for an as-need basis. Water heating supply is provided from a heat pump system with storage tanks located behind the boutique spaces. Additionally, the cafe kitchen hot water supply is provided by a CO2 Sandco tank and a heat pump system, which provides inherent cooling within the kitchen space and an excessive amount of hot water supply. Moving on to our lighting design. With abundant daylight availability, our goal was to allow daylight to permeate the residential units. Through the addition of blinds and an interior light shelf, we mitigated overexposure while maintaining strong daylight autonomy. Similarly, the commercial spaces maintain strong daylight autonomy while further reducing overexposure. This is accomplished by using blinds, awnings, and furniture. Moving on to our PV metric system, there will be a 230, 440 watt solar array and a 100 kilowatt system. Each AC panel is fitted with a microinverter, allowing for decreased shading losses due to debris. The panels will be mounted on a fixed ballast system at a 30-degree angle facing south. And ideally, this system should produce close to 500 million BTU per year.
Thank you, Severin. After our preliminary cost analysis, we found that we needed to implement additional strategies to make Growing Haven both net zero and affordable. Therefore, to offset the upfront construction cost, we created two affordability strategies. One strategy is that homeowners could purchase a rental unit on their floor and then use it to generate income. The other strategy is to utilize the commercial boutique and cafe spaces to generate profit that will offset the maintenance cost for the entire building. Additionally, we researched multiple grants, rebates, and subsidies, which can be a good option to help lower initial construction costs. Thank you so much for listening, and we'd like to thank our excellent teammates, industry partners, and wonderful faculty advisors.
Great. Thank you for your presentation. I'll open it up to Sarah and Lou for questions.
Thank you. That was a great project, very thoroughly researched, and I really appreciate the realistic approach to your building system selections. I can tell you used industry resources to help your design. I mean, cost is a very significant factor in whether or not a project can be built. And with specifications like this, I think this is a building that would honestly get built. So I had a question about your water heating system. The heat pump water heater, I think that's a great choice. It's something that we've been pushing in our all electric designs. Is this a central heat pump system or was it in unit? I saw you had the specs up, but
It's there. Each residential unit will be provided their own heat pump water heater. We recognize that they're a lot louder because of that, so we put them in the central corridor where the acoustics could be taken away from the residential spaces.
That's great. And you considered like the additional cooling load that it puts into the space as well. Great. No other questions.
I really like the project that you talk about affordability strategies. And I think that's very impactful for the community. So I really like that. Do you know what is the walkability score of the project?
It's 80, I think. What is 80? It's about 80, we think.
Great. And what is the cost for per square feet?
We've got that to about $340 per square foot, but given some more rough estimates, we're looking at getting that lower through different concrete design and wall thicknesses. Because the main cost of our structure, our main cost of our building is the structural components.
Yeah, that makes sense. The numbers make sense.
Yeah, I just want to say that your decision with using concrete for the wall, it is a trade-off. It has high embodied energy, but it also provides mass to the walls, which provides passive heating and cooling. So yeah, there's no perfect material.
We looked into a wood frame structure that was thermally broken, and it was nearly double the cost. So we thought this was a much more efficient process.
Yeah.
I didn't hear about this, but maybe this question will open for further conversation. How the resilience strategies will affect certain populations, since this is a affordable project and it has a very cultural impact. And this is good that you start to think about resilient strategies for this community.
We're very proud to work with Sunshine Gospel Ministries on creating something that will build the community there and create a very inclusive environment that just makes this street very, very accessible for all of our Chicago friends.
There are no further questions from Sarah Booth. All right, thank you, Illinois Institute of Technology, for your presentation.
Thank you so much.
Thank you.
All right, next up will be Northeastern. We have a bit of time, about 4 minutes until that presentation starts, but feel free to share your slides whenever you're ready. We got a little less than a minute for the presentation start time, so you are welcome to do some audio checks and then we can get started.
Assuming you can hear me okay? All right, great.
Sounds good, Ted.
Good morning. Hope y'all can hear me okay.
Yes.
Good morning.
All right, we're at time, so you're ready. Welcome to start.
On behalf of the Northeastern University Solo Decathlon team, we'd like to present our semifinal submission for Cardinal Plaza.
There's been quite a bit of development since our first iteration, but through an integrative interdisciplinary design charrette approach, our team was able to identify several key factors that have since been developed upon for this new iteration. Boston has a long, rich, and oftentimes complicated history. This has provided us with several key aspects to help us better understand and design to our site. Our site is also located among several important transit corridors, most importantly, the Silver Line, which is a bus rapid transit system that runs from our neighborhood of Roxbury to Chinatown, downtown, and the airport, and the Silver Line is located just a block off our site. Our site is broken down into 3 large residential blocks, as well as a cluster of townhomes. To start with, our east building, along with its residential, also has retail commercial space, common areas for the residents, and a large expansion for Rosie's Place, which is the oldest women's shelter in the country, which has both its administrative and its operations located just adjacent to our site. Our north building is our most dense residential building. It consists of mainly studio and 1-bedroom apartments and it is an all residential building. Our west building is home to our largest commercial retail space. It also contains covered parking, a gym for the residents, and a green roof. One key design concern that was identified was trying to find and maintain a balance between private and public use of the site. This was done through the general layout of the massing, as well as specifically curated program for the site itself. Going into more detail about our buildings, starting from the outside in, our facade is a rain spring cladding system using 2 different materials, one being an Equitone fiber cement panel, the other being a charred white cypress wood panel.
Working with RDH building science, we've been trying to perfect our building enclosure to make sure it's not only energy efficient, but also easily constructible and free of any headaches on the general contractor's end. We've adopted a modular EIFS wall panel system with a 3-ply CLT backup wall, as well as a semi-permeable and semi-rigid insulation, which allows water to outwardly dry. We also have a proper air and water barrier. We hope that this system is not only easily constructible for installation, but it also avoids any potential water penetration of the CLT members in the construction process. And then for our structural systems, we are using a post beam and panel system for our 3 main buildings, along with general wood framing on our south townhomes. This system allows us to buy all of our structural members in bulk, and with the post and beam system, we are allowed to have various spans of various lengths to match our different unit sizes, as well as our modular wall panels themselves.
For the MEP systems, there were several selections that were made to promote energy efficiency. Our main criteria for selection were energy efficiency, durability, and price, respectively. To start, an important selection came with the HVAC systems. For our system, we are planning on using metered heat exchangers along with heat recovery ventilation to ensure that efficient and effective heating will be supplied to the building. For our electrical systems, we are observing several incentives such as Mass Save and Clean Peaks, incentives given by Eversource and the state of Massachusetts, respectively, to promote the load reduction on the grid by buying energy back from on-site production. With this design, we will be connecting all of our buildings with a virtual power plant. All 4 of our buildings will have on-site solar production and storage of at least 10 kilowatt hours per unit and will be connected through SPAN smart panels. Each of these buildings will be connected as to reduce the reliance on the grid, along with being able to sell back power to the grid as production goes beyond demand. To create the most energy efficient envelope, several design iterations have been worked through. We began with the box model and have been working through energy models along with different design iterations to create an efficient envelope. We are still working through this process. Due to an unfortunate error in our submissions, our carbon emissions and utility costs were overlooked. The total carbon emissions for these 3 buildings would be 319 tons per year. This number was generated using the nationwide average of 0.818 pounds of carbon per kilowatt hour. This number would be much lower as further energy efficiency is implemented, on-site storage is accounted for, and the true emissions of energy pulled from the grid accounted for. The total utility cost for this building per month would be at maximum $10,500. This value would be greatly reduced as the energy model is refined, energy buyback completely accounted for, and the aforementioned incentives. With respect to the plumbing systems, we have decided to use tanked electric water heaters along with thermodrain heat recovery. With the use of thermodrain heat recovery, it is predicted that under conservative estimates, it will reduce the load on each hot water heater by 25%. All of our fixture selections were made with reduced water use in mind.
As mentioned, our site is also home to a collection of townhomes. There will be a total of 18 3-bedroom units in these homes, designed with the young family in mind. This will create a family-oriented community within the larger Cardinal Plaza community and the neighborhood of Roxbury. The more precise plans and layout of these units are still in development.
If you talk to any developer in Boston, you know that it's hard for things to be approved, which is why it was a priority for us to actually design something that could be built in the city. Because our site is so large, encompassing multiple streets, we would be in what's known as a planned development area, or a PDA. We've already started considering how this PDA would be approved by the city, and additionally, what review elements were considered for each individual building. For our north building, as it's over 50,000 square feet, would go into Article 80B, what's known as intensive large project review. This has additional measures we have to consider, such as being LEED Gold and meeting 1.25-inch stormwater retention. It's also no secret that Boston is expensive, recently surpassing San Francisco to be America's 2nd most expensive city to rent 1-bed, studios, and most general unit combinations in. Using our own experiences from our ongoing build competition, we were able to create an in-house tool to compare and analyze different affordability ranges for our site. For our north building, we have a dense array of studio and 1-beds being sold at market rate. And using the surplus we have from the sellback, we were able to subsidize our east and west buildings with a large amount of affordable units, all the way down to 30 and 50 of the area median income, which can be considered deeply affordable. This is able to supply a lot of market rates units for the booming population of young professionals, particularly in the biotech and medical spaces, while also supplying units for the long queue of longtime residents in the city who need these income restricted housing stock. And obviously, we've had a large change in design in the past month, but now what we're working, we believe, is a strong foundation for our project. We'll be moving forward to perfect it and just add more detail on all the different categories. Now, questions. Thank you.
Thank you for your presentation. I'll open it up to our jurors for Q&A.
Thank you, guys. Can you tell me more about what you're doing for the HVAC design? What's your system selection for space heating and cooling?
So for our systems, we are planning on using air source heat pumps. We've been looking into the Lennox systems, primarily due to their performance with cold climates.
Great. And then for the domestic hot water, you mentioned drain heat recovery. I think that's great. Is this being paired with a gas or an electric water heater?
Electric water heater.
Gotcha.
I really like the analysis about the market, but tell me a little more about the demographic of the market for this project.
Yes, so our neighborhood is really dynamic. It is a very dense neighborhood. We're on the verge of South End and Roxbury, and specifically, there is a large working class population. There is a lot of public housing around our neighborhood, as well as just general, I think, market rate brownstones. So there's a large class disparity within the neighborhood, which is why we need a lot more of what's considered the missing middle in Boston. And in particular, on kind of the higher end of that missing middle, we need just more like basic, smaller studios and one beds to meet a lot of the growing student population in the area. We have our university nearby, as well as Boston Medical Center, which has a lot of medical students and students on residency who aren't able to afford a lot of these really high-end luxury developments around the hospital. And especially since they are late night workers, being close walking distance is a high priority.
Right. So based on that, I would like to know a little more about your wellness strategies.
Yes, so we have several thoughts around our wellness strategies, both within the buildings themselves and also in the exterior. Providing a large green space is, our number one idea around this. We want to create an urban oasis that's accessible to the entire community. So there will be several aspects within the site, such as a healing garden, creating sort of a meditative space, as well as there are different ways to design with both with adult exercise and children's exercise in mind, creating nature play and also just integrated exercise equipment in the landscape, and providing views for all of our residents of greenery, hopefully year round, using a mix of evergreen and deciduous plants. We hope to create, a very safe, comforting atmosphere for all our residents and as well as any visitors to the site.
I really like the site plan. I think it's interesting. It has kind of like a campus aesthetic to it. I'm curious about the architectural design elements that were considered for the buildings themselves. It's more on the simple side. Is this an effort to blend in with the surroundings, or was this like a cost-cutting measure?
No, do you mind going back to our urban context? I know we didn't touch that slide. If you just go back. So the area, we're in kind of a transition area within Boston itself. So we're between the area of South End, which has a lot of very traditional brownstones, as well as a lot of public housing projects from, the mid 20th century, 21st century. But there's also, we are right next to Newmarket, which is a very heavy industrial area. It doesn't have a lot of residential. And as part of Plan Newmarket, which is a new urban planning initiative, they're actually asking for kind of a transition to create more mixed uses. In the case of our site, we are on this kind of urban edge of this kind of new industrial space. And we're hoping that we can kind of capture the mix between neighborhoods. So we have this more beigey tone that matches a lot of South End and Roxbury, but also its blockiness matches a lot of the industrial form of Newmarket.
Gotcha. Thank you.
We're just reaching the end of Q&A. Any last questions from Sarah and Lou?
Yeah, I think I have the last question about the resilient strategies. I saw your material selection. I was wondering how that will work with flooding in the city.
So yes, flooding in the city is definitely a large concern. Boston has identified part of our site being within a 50-year coastal floodplain as sea levels rise. There is a very heavy emphasis on designing green infrastructure. So hopefully our material selection of the buildings themselves can avoid any flooding risk with the use of very intensive green infrastructure. That is still being assessed as to what strategies make the most sense for what the type of flooding we'll be seeing. But on the section of the site that has been identified as within a coastal floodplain in the next 50 years, there will be several strategies implemented.
That's all the time we have for Q&A. Thank you, Northeastern, for your presentation.
Thank you.
Thank you very much.
Thank you.
Thank you.
Right, next up, we have Carleton University. You are welcome to share your slides whenever you're ready. If you want to go ahead and do a quick mic check for all your presenters, then we can get started.
Okay,
Good
hi,
morning.
I'm Isaac, Ali, Ilyas, are you here too?
Yep, I'm here.
Sounds good. Audio is clear. All right, I think we're right about at time, so you're welcome to begin whenever you're ready.
Okay, awesome. So first of all, hello and good morning, everyone. I want to start off by thanking you judges for being here today, the audience members, and our supervisor for being in attendance. We're the Green Maple team from Carleton University, located in Ottawa, Ontario, Canada. Our team is composed of 6 members, as you can see on the screen: myself, Matt, Ilyas, Ali, Braden, and Jasmine. And together we've developed a set of 4 distinct design goals for our project. Our first objective was to achieve a net zero resilient design capable of being durable throughout Ottawa's harsh climate. We wanted to achieve this goal while maintaining affordability, both for the developers, but also for the occupants in the back end, so they don't have to pay a premium to live there. Our third goal was to inspire the next generation of developers. Through our research, we didn't find much in the way of developers demonstrating effective long-term net zero construction, so we want to change that in the community. And lastly, we wanted to create and foster community interactions through social engagement and safe environments. The 2 images you can see on the screen here, the left one is the plot of land that we're proposing development on, 3248 Greenbank Road. And on the right-hand side, you can see the contextual view of Barhaven's proximity to the downtown core of Ottawa. So we're a little bit south of it. Barhaven currently has a population of 100,000 individuals with a 5-year growth of 13.5% and an average household income of $145,000 per year, and that's in Canadian. The road chart shown on the bottom of the page breaks down the demographics of homeowners currently in the community, with the vast majority of people owning homes in the middle age, so from 35 to 74, with only 17% being owned by people under the age of 34.
For the architecture, based on our design goals, we went through different design iterations to find the best possible form, layout, and materials. As you can see from the figures, the site is a flat open site with views in every direction. Local brick masonry and timber will be used for the structure. Passive systems such as side fans, rainwater collector, and ground source heat pumps were all introduced to achieve net zero and resiliency, which will be explained further in the presentation. As you can see from the floor plans, there are a total of 4 stories with 3 upper residential floors and a commercial ground floor. It was decided to have a commercial shops at the ground level to push towards community engagement and social interactions. In terms of the residential floors, there are a total of 9 residential units, and each unit is designed for different lifestyles and family configurations by offering different numbers of bedrooms and different sizes of kitchen and living room. And finally, as you can see from these architectural sections, a number of stories are further visible. And as you can see, we have also considered landscape design, and we try to design the landscape in a way that occupants could enjoy the greenery.
So shown on the screen are 3 different wall assembly layers. The foundation is rated as R50, exterior walls are 38.7, the roof is 82, and the window has a U value of 0.8, so in R value, that's 7.1. The high thermal R values come as a product of Ottawa being located in a 6A classification climate zone. And as a result, the exterior temperature and wind conditions have a pretty crucial and dramatic impact on how to design efficiently. Last year alone, Ottawa saw a low of -16 degrees Fahrenheit and a max in the summertime of 91 degrees Fahrenheit. And that's excluding the humidity effects. For heating, there's a ground source heat pump with boreholes drilled below the frost line in Ottawa, which is about 4 feet. The heat travels through in-floor heating and is serviced in every single zone, residential and core spaces of the building. Ventilation is provided through 3 individual RTUs. On the right-hand side of the screen, you can see there's 3 different zones in coloring. There's a blue, a green, and a orange zone. and each zone has distinct loading demands and therefore has a unique RTU that services each zone. Another design solution that we considered was the rainwater collection system. So a portion of the water is going to be absorbed into the green roof, but the remaining runoff will be collected into cisterns that can be used for gray water systems, so toilets, for example. And in the case of a power outage, filters can be utilized to convert this gray water into potable water for drinking or showering, etc.
For the market analysis, we calculated an initial investment of $8.7 million, broken down into 4 phases. Site and construction, PV and mechanical systems, exterior and interior finishes. We found an affordable rent price of $2,500 based on the average median household income. We also took an average commercial lease for the Barhaven area at $52 per square feet. As a rule of thumb, 1% of the property value was used for the annual operating and maintenance costs. With this data, we got a payback period for the initial investment of 29 years. For durability and resilience, we modeled the building's energy systems for the most energy-intensive week of the year. We designed the system in the event of a power outage to have enough battery storage while charging and discharging with photovoltaics to be resilient over the course of that week. 4 embodied environmental impacts we focused on was wood frame construction, locally sourced masonry bricks, no use of natural gas, and an on-site renewable energy system. The PV system uses 171 PV modules connected to 2 inverters that either transfers electricity directly to the user or stored to be used at night. The diagram on the right shows the PV system's losses to attain the required energy.
Based on the Ottawa latitude, overhangs were designed to completely shade south-facing windows in the summer and allow all solar heat gains in the winter. Side fins were incorporated on the east and west facades of the building. They ensure that there's shade after 10 a.m. in the east and until 2 p.m. in the west. As far as pleasing occupants goes, there's lots of green space in the surrounding area. Bedrooms are distant from elevators, so disruptions won't occur. Living rooms are all on the south facade of the building, which means more sun will be provided to the occupants. And stairwells are designed to ensure proper egress. A main comfort design of the building was to include the 4 categories of indoor environmental quality, which incorporates extraordinary indoor air quality, provides acoustic comfort through soundproofing, overhangs and side fins provide visual comfort to the occupant. And since Ottawa is in a extreme climate, if you will, excellent thermal resistance is provided, as well as operable windows in the summertime. So kind of gives the occupants a sense of control, which ultimately makes them more satisfied. The energy modeling process began with software such as eQuest, then Energy Plus, which eventually moved to Design Builder, which is where we found our successful results. Using an applicable site or source to site factor for electricity for the region, an energy usage of 48.2 kilobtu's per foot squared per year was found, which is less than the solar decathlon requirement. And as said before, we're in predominantly heating climate, so roughly 60% of the energy use goes to space heating. And PV generation is more than sufficient to counter the energy uses for 8 months of the year, in which the extra energy will be sent back to the grid. For 4 months, though, in the colder, more energy-intensive months, it'll be required that electricity be used from the grid. And with the addition of commercial space on the first floor, peak energy times can be offset to limit efficiency losses through energy storage.
We want to thank you for your time and ask if you have any questions.
Thank you for your presentation. I'll hand it over to Luz and Sarah for Q&A.
Thank you. This is a very interesting building design. I like the variation in the overhangs. And for landscaping, I like that you added a lot of green space back into the building, especially since the site is built on an existing green space. Can you tell me more about your envelope design and how you came to your envelope R values? At first glance, the foundation insulation seems very above code, and the windows, I think that's the R value we see for like single pane windows, which I'm sure is not the intent.
Sure. I don't know if Matt, if you want me to handle this one. It might just be a conversion issue. First of all, to address the window question, converting everything from metric to imperial, and we might have just mistaken that conversion. So we apologize for that. Our U value that we designed for is 0.8. That's including the frame and it's a triple paned low emissivity windows for the south facade. The R foundation value is rated as R50. Again, this may be a conversion issue. We apologize if it isn't, but the goal of designing for the high thermal R values is because in a climate where the freeze and thaw cycle is very, very high, a lot of moisture and cold is kind of absorbed in the top layer of the ground. So we want to make sure, because it's a slab on grade construction, that we have a proper insulating foundation in particular.
Thank you.
I have a few questions. It looks like a isolated area. What are the existing amenities of the area, and how you are like designing a deficit of these amenities?
So it is located about a 5-minute walk from a bus station. There is a very large commercial space. It's one of those areas that has a lot of grocery stores and the parking lots and a lot of strip malls, but it is about a 5-minute walk. So it looks a little bit far in our site plan, but if you do zoom out a little bit, it is relatively close.
Thank you for the clarification. I don't know if you did an assessment of climate risk, and what are your proposed resilient strategies?
Yeah, so we had a number from Design Builder. It gave us an estimate of 675 tons of CO2 per year from off-gassing energy consumption of materials. We are also including local masonry on the exterior, and then on the interior, we are planning to use local timber for the framing.
I like your MEP system with the RTUs and the VAV for space heating and cooling. Is this also used for ventilation? I think I saw somewhere that you mentioned natural ventilation, but I wasn't sure if that was going to be through windows or with the RTU.
Yeah, so it should be a mix of both. It is mostly through the RTU, but it is a little bit difficult. So since all the units are separate inside the building, we can't have the cross ventilation going all the way through. So the units, some of them are on the corners, since there are 3 units for the floor. So you can get a little bit, but it isn't going to be, unless the angle is perfectly aligned, you're not going to get a whole lot of ventilation that goes right through from the operable windows.
Thank you.
Time for one more question. Sarah, Luz, if you have any. If not, I think we're about ready to go to break. All right. Well, thank you, Carlton, for your presentation.
Perfect. Thank you.
Thank you.
Have a good
Thank you for having us.
All right. So we are now, we will have about a 10-minute break. We'll reconvene with Toronto Metropolitan University at 11:20 a.m. Eastern time. So we'll make sure to join a couple minutes before that so we can share slides and do audio checks. We will see you all in a bit. Hi, everyone. Welcome back. All right, we have Toronto Metropolitan University up next. So whenever you're ready, you can start sharing your slides. And we have about a minute till the presentation starts.
Perfect. Thank you.
Right, we're at 11:20 Eastern time, so whenever you're ready, take it away.
Great, thanks. Hi, everyone. Our names are Bree, Noor, Nick, Mitch, and Jim. We represent Toronto Metropolitan University. We're excited to take part in this year's Solar Decathlon Design Challenge. We can't wait to show you what we've been working on. In this presentation, our team is going to tell you about how the building we've designed excels in each of these contests. But first, we want to tell you about the location we chose for our building. Hamilton calls itself the city of waterfalls, boasting over 100 within its boundaries. Located in ASHRAE Climate Zone 6, Hamilton is a cold climate. Due to its proximity to Toronto, Hamilton is growing quickly and has a population of 750,000 people. The population in Hamilton is varied. Young people entering the workforce and hoping to buy their first home, growing families with young children, older individuals hoping to downsize. But finding an affordable home is a struggle. According to the American National Association of Home Builders, only 42% of new and existing home sales in America are currently affordable to a typical household, and the story isn't much different here in Canada. We wanted to develop a way to give this market, for those in Hamilton and those across the country, an opportunity to enter the housing market. Here you can see an aerial view of Lime Ridge Mall. Lime Ridge Mall is located on Hamilton Mountain, tucked in amongst single-family homes, big box stores, transit routes, and amenities. The mall is fully surrounded by acres of parking lot, or, as we see it, underutilized land. It's in one of these parking lots where we propose our building.
Our building, dubbed the Cascades, references the waterfalls of Hamilton by utilizing stepped architecture that cascades downwards towards the south, thereby allowing maximum daylighting into the units. The building is crowned with a wave of hybrid solar thermal panels, which offers benefits from its equatorial orientation and generates as much power as the building requires. The units are designed as modular and prefabricated, which offers many benefits, one of which being a unique scalability of our design for many lot sizes. Lastly, the courtyards and breezeways offer spaces for play, relaxation, and community connection.
The Cascades energy strategy is to provide a high-performance envelope that reduces thermal energy transfer and air infiltration through the walls, roof, floor, and windows. The envelope will be detailed to reduce thermal bridging and allow high R-value assemblies, such as R32.5 effective walls. This will ensure that occupants of the Cascades will be comfortable in Hamilton's cold climate. A hybrid solar thermal panel array at the roof level of the building will provide all heating, domestic hot water, and electrical demand for the Cascades residents, generating a potential of 454 kilowatts of on-site electrical power. The low TEDI approach allows us to utilize highly efficient mechanical equipment, such as the solar thermal panels distributed by a radiant floor heating system, cooling provided by an air-to-water heat pump tied to in-suite fan coil units, all powered by on-site renewable electricity. Prefabrication of the modular units will minimize construction duration, reduce waste, and provide high-quality control. The goal of the Cascades development is to provide affordable and high-performance housing to a maximum number of people. Our model is a cooperative housing complex that aims to set rates which align with median incomes for the area. The unit costing is based on actual construction costs rather than a market-driven value. Occupants in the typical market-driven housing spend higher percentages of their income on housing utilities, resulting in less available income for savings, food, etc. Our model provides affordability with a high-performance envelope, so occupants of the Cascades spend less of their income on housing utilities, leaving more available for discretionary savings and spending.
Several strategies act to ensure that the durability of materials and systems that go into the Cascades. Materials used in construction of the Cascades will be chosen for their longevity, which serve the life to match the age of the building. A Wolfe hydrothermal analysis will ensure long-term durability of the building envelope. Passive design strategies and on-site electric storage will ensure occupant comfort during short-term power losses. Water collection and storage will ensure water security and reduce reliance on the municipal systems.
Our approach to reducing embodied carbon at the Cascades begins with modular construction. Modularity and manufacturing offsite increases build quality, reduces waste, increases on-site construction efficiency, all leading to a reduced embodied carbon impact. Each module will be constructed of mass timber elements and clad with fiberboard insulation, which each have significantly reduced embodied carbon as compared to their traditional steel, concrete, and XPS counterparts. These products also have the added benefit of sequestering carbon for the lifespan of the building. Where concrete is required, high supplementary cementitious materials, fiber reinforcement, or high recycled content rebar, and 50+ day cure times will be employed. The Cascades will make use of recycled content to the furthest extent possible and will be zero carbon certified through the CAGBC.
In addition to the physical systems which contribute to energy efficiency, community-oriented technologies such as smartphone apps and smart touchscreens will inform residents of the energy performance of the building. Access to this information will involve the occupants in the Net Zero initiative, which will contribute to energy demand reduction.
In each unit, natural materials, functional layouts, and interior daylighting will improve the occupant experience at the Cascades. But now we want to go beyond the unit itself and tell you about the building's shared spaces in connection to the wider community. Our building is designed for anyone who needs affordable housing. Rooftop patios, indoor amenities, and breezeways and courtyards offer space for families to play, individuals to meet and relax, and encourages connections with neighbors. Located in an already developed area, the site is well connected to the larger community. Transit routes, grocery stores, medical centers, gyms, shops, and parks are all within a mile of the building. One of the most important strategies we have employed to achieve a comfortable indoor environment is an emphasis on daylighting through thoughtful window to wall ratios, building orientation, and stepped architecture. This image shows how deep into the unit the sunlight reaches all the way back to the kitchen. The second image shows how beautifully lit the living spaces in the units will be, creating a connection between the indoor and outdoor environment. In addition to these daylighting strategies, occupant comfort is achieved through smart ventilation strategies, low VOC finishes, unitized temperature control, sound isolation between units, and soft artificial lighting.
Baseline energy modeling shows an energy use intensity of 67 kilobtu per foot squared per year, which will be optimized as our design progresses. The baseline energy breakdown can be seen here, with heating loads dominating energy consumption. Energy conservation measures that will be implemented to reduce our energy demands include reductions in thermal energy through the use of solar thermal panels, air source heat pumps, and energy recovery ventilators, each in combination with our optimized building envelope. LED lighting systems synchronized with outdoor daylighting conditions and energy efficient appliances will reduce our overall lighting and plug loads. And finally, a building automation system paired with active sensors will identify additional operational schedule efficiencies within the building. Through this process, we hope to achieve an energy use intensity of 19 kilobtu per foot square per year or lower prior to the consideration of on-site energy. Here we can see our on-site energy production to the left, with annual PV production estimated to be roughly 500,000 kilowatt hours and solar thermal being an estimated 1.28 million kilowatt hours. Our target energy breakdown can be seen to the right and accounts for a total energy demand of roughly 964,000 kilowatt hours.
Thanks to the U.S. Department of Energy, the jurors, and the judges for giving us the opportunity to create and share with you this exciting project. We have a couple final tasks to complete. Here you'll see a plan for how we intend to complete this project. Thanks so much for your time. Have a great day.
Great, thank you for your presentation. I will turn it over to our two jurors for Q&A.
Thank you. That was a great presentation. Very interesting design element with the wave panels as well. I'm assuming a steep trade-off in cost and efficiency. Is this based on an existing design? And if so, what are the assumed losses in efficiency?
I can take that one on. Yeah, so this isn't, the waveform isn't necessarily based on any reference architecture that we have, but our professor does have a building, one of the educational facilities that does have a suspended array over the building. And so if there were like substantial losses from the waveform, we could sacrifice some of that that massing to get the efficiencies we need. So it would be more sloped towards the south and flatter, et cetera. But we would have to look into the how we could optimize the design for that. Yeah.
Gotcha. And I think the air source heat pumps and the ERV is a great MEP design. Have you considered where the outdoor condensing units will go on this building? Is it going to be on the rooftop or?
They would be rooftop mounted, yeah.
Gotcha.
Really nice presentation. And this is just a question outside of the project. And because of climate change, nowadays we have more people that are displacement by natural disasters. Have you think in any community solutions for displacement people?
So for the community solutions, having the large green space is actually, we're moving this paved surface of the parking lot. We're actually allowing a lot more water to filter into the ground. So we're going to be, if with climate change, we're seeing more flooding, the site will actually be able to handle a lot more water from its surrounding sites and then prevent flooding in the surrounding community.
And another important piece of the puzzle was we really wanted to be able to provide housing for as many people as possible. So that informed our decision to make the units modular that could be repurposed and put into any infill site. Of course, the massing of the building, the solar panels are going to look different, but the units themselves could be put into any site to offer as many opportunities for homes as possible.
Yeah, I think that modular design is great. Can you tell me more about the building material for the envelope and the insulation?
Want me to jump on this, guys? The insulation we're proposed using at this time that we've done our preliminary models with was a wood fiber board on the exterior walls, poly iso on the roofs. Again, I think the effective R values for the walls in the preliminary modeling was around R32.5, with the roof coming in at around R55 effective values. One of the key areas that we're focusing a lot of attention on is on the detailing and the transitions to ensure that we're reducing the thermal bridging.
Thank you.
Any additional questions from Liz or Sarah? All right, well, thank you, Toronto, for your great presentation.
Perfect.
Thank you
Thank
all.
you, everyone.
Yeah.
Thank you for having us.
All right, next up, we have University of Minnesota, Twin Cities. Your presentation will begin at 11:35 a.m. Eastern. So we have about 4 minutes. We'll touch base in a couple minutes for you to show your slides. A little less than a minute until the presentation time. So if Minnesota, if you would like to share your screen, you're welcome to do so at this time.
Good morning, everybody. Can you all hear me?
Yes, audio is good. Is there anyone else on the Zoom call presenting with you? We can do an audio.
Yeah.
call.
Yep.
I'm here.
There's also Will. Yeah.
Great. Can hear you well. All right. Yeah, we're about at time, so you're welcome to start whenever you're ready.
Cool. All right. Good morning. There has never been a greater challenge for multifamily housing than there is today. The need to balance affordability, net zero performance, and health and well-being has never been more important. We are the North Star Modular team, and we are here to take on this challenge. And thank you so much for the opportunity to share our proposal for the Solar Decathlon Multifamily Division, North Star Healthy Home. My name is Jacob, the team lead, and I'm presenting today with Will, our systems lead. And here at the University of Minnesota, we have a strong interdisciplinary team of students and industry partners. Together, we will transform a brownfield site located in North Minneapolis into a healthy living environment for a community of growing families. By leveraging modular construction and healthy low carbon building materials, we can deliver a high performance building that supports the health of its residents and the environment. Looking at the demographics of the Near North neighborhood, we recognize a need for housing that is both affordable and able to accommodate a growing family. With 34% of the residents under 17 years old and 68% of those households making under $75,000 a year, we are providing affordable housing at 50 to 60% AMI with an emphasis on 3 and 4 bedroom units. We are confident that with the help of our design partners at UrbanWorks, we can provide a safe, affordable housing option that supports the needs of low-income families of color. When it comes to multifamily housing, we believe human and ecological health comes first. Our design goals are driven by a commitment to a non-toxic, low-carbon material criteria that incorporates trauma-informed design and biophilic principles. Volumetric modular construction supports our vision for a high indoor environmental quality by allowing us to ensure the highest degree of control and consistency throughout construction. We hope to go beyond net zero performance by providing a valuable addition to the community of North Minneapolis. Our site is a historically redlined residential area that has been further isolated by the development of highways to the north and east. Despite those challenges, there's a rich variety of parks, schools, cultural centers, and public transit, all within a half-mile radius of the site. Being climate zone 6, we experience 110-degree temperature swings from hot, humid summers to very cold winters. We are familiar with the unique needs of a harsh climate and will continue to work with our modular manufacturing partners at RISE to design a building that is resilient and climate appropriate. As part of a larger master plan for the site, we use modular construction as a prototype to create a community of spaces for families to live, play, and grow together. We're creating a residential scale multifamily building that responds to the existing character of the neighborhood by offsetting and clustering modules. So the focus of our proposal will be a 32-unit, 5-story building on the northwest corner of the site near the lake, with a commercial corner store on the first floor to boost walkability and support the local economy's need for reconnection. Our building is made up of 96 prefabricated wood frame modules, each certified for installation under the state of Minnesota's code. Each module is 12 feet wide, 64 feet long, and 13 feet high, allowing us to transport modules to the site without the need for a special permit. Modular construction is often stereotyped as architecturally restrictive and boring, but we believe our project demonstrates how modules can create an appealing living environment that performs better than traditional buildings while blending in with what exists. By offsetting modules, we create a variety of spatial layouts, sightlines, and a dynamic building form that supports an occupancy of 227. The first floor has a commercial corner store supported by a CLT podium and a breezeway to boost site access. Each floor above that is primarily residential with a community space located above the breezeway that serves as a flexible space for residents to share and build relationships.
We will be using a precast concrete foundation with 2x8 wall construction for the modular portion of the building and an inverted flat roof. The foundation will have rigid insulation on the outside of the water, vapor, and air control layer with a robust drainage system surrounding that foundation. The 2x8 framed walls will be a hybrid wall system featuring exterior insulation with cladding that can drain and dry. The flat roof will have an EPDM membrane under rigid insulation and ballast. And this use of foundation of insulation and control layers will lead to a continuous thermal, water, air, and vapor envelope around the entire building. Creating this continuity will lead to superior moisture management and little heat exchange. This will be challenging with prefabricated systems and modular constructions, but it is something we will look into and continue to solve. The focus of our occupant experience is rooted in the health and well-being of the residents. By using nature-based color palettes, we can integrate biophilic strategies and trauma-informed design principles that respond to the needs and experiences of our target market. Each unit supports the needs of a growing family by providing flexible spaces, lots of storage, and resident-controlled systems. Building on our ideas about occupant experience, our focus on comfort and environmental quality takes us from design principles into application. We're using toxicity, global warming potential, circularity, and third-party certifications as our criteria for material choices. Modular construction combined with our building control layers yield tight interior and exterior acoustics and odor separation, reduces moisture, and increases thermal comfort. Each home is fitted with an individualized thermal controls and spot ventilation in the kitchen and bathroom, as well as makeup air. Currently, we are looking into implementing a ground source heat pump to provide air conditioning and hot water, as well as an air to water or air to air heat pump. The ventilation system will be balanced using an ERV and a MERV 11 filter at minimum. This will filter out harmful particles as well as unwanted smells. When it comes to structural loading, instead of the primary structure being the facade and corridor of the building, the loads are carried by the shear walls. We are currently using Sapphira and PV Watt as a starting point for our energy modeling. With a low window to wall ratio of 15% and high building performance EUI of 21, we see a lot of opportunity for improving daylighting while balancing energy use. Roof mounted PV is limited, but can provide an estimated 60% of building electricity. Having an all-electric building allows us to explore opportunities for off-site renewable energy to reach net zero. All in all, we are proposing a family-oriented, healthy living environment that seeks to go beyond net zero performance while responding to the needs and experiences of a unique neighborhood in Minneapolis, Minnesota. Volumetric modular construction will enable a higher degree of control that is cost-effective, minimizes waste, and facilitates a high-performance design that champions excellent indoor environmental quality. We recognize that cost estimating and a full life cycle analysis of building materials is going to be a fun challenge. With the help of our industry partners, we are looking forward to the next steps. Thank you for this opportunity to present. We are happy to answer any of your questions.
Great, thank you for your presentation. I'll hand it over to Sarah and Luke for Q&A.
Thank you. Great site selection and design. I love that this project is focused around addressing some critical affordable housing issues. It's very thoroughly researched on all fronts, from envelope assemblies, which look great, the MEP system, the resident central design. Yeah, great job. Can you tell me more about the trauma-informed design piece?
Yeah, so You know, in the United States, trauma is a pretty common experience, especially with communities as low-income communities and communities of color. And so there's really these principles of, what is it again? These principles of like trying to promote safety and care, personalization, and like healing and recovery. And so trying to integrate different aspects throughout the building and as well as throughout the site. And that can be just like as easy as creating intuitive spatial layouts. It kind of overlays with biophilic principles as well, with nature-based like colors and patterns, you know, maximizing daylight. Yeah, but we just recognize that, you know, creating a house that really feels like a home is really important for this community.
Thank you. Second question. So Minnesota is a pretty challenging climate. Are you thinking about any kind of backup heat source for the heat pumps for either the space heating or the domestic hot water?
I'll pass that on to Will.
Yeah, so far we haven't looked into backup heating systems for the hot water and air conditioning, but we think a ground source heat pump in our area will be able to provide all of those things. We've looked at air source heat pumps, and due to how cold it can get here, it's -10, or it was yesterday. Air source heat pump would not work as well, but we think the ground source heat pump is a very good option for our building.
Thanks.
This is a great project. I really like that you focus on health and lower carbon and modular construction. I think that focus on wellness is a strength of your project. I really like that. I have a question about you mentioned the appealing of the modular design and the trauma design. So I am having a hard time of seeing that element in the design. The architectural design looks a little simple. And tell me more ideas that you have about creating a sense of belonging for people of color. There are certain design elements and aesthetic elements that will create that.
Yeah, so more examples. So we're still trying to figure out the facade of the building. We want to blend in with the existing neighborhood to have like a more residential feel. That's why we've kind of offset the modules so it doesn't feel like one big sort of warehouse of people, you know. But for the trauma-informed design strategies, we've really tried to focus on like clear sight lines. You know, originally we had this design charrette where we put the staircases at the end of the hallways, but it actually blocked sunlight from getting into the hallways. And so, you know, coming back to trauma-informed design like principles as like a way of reorganizing space so that like the hallways are well lit, there's access, there's like access to outside. Also, you know, a lot of that has to do with like providing like visual connection between spaces. So we have like a community space that we're kind of thinking of like the building's living room above that breezeway. And instead of just creating one big event space, it will be divided into a larger space, a medium-sized space, and a smaller space, because a lot of that also, you know, has to do with empowerment. You want to, you know, provide like personalization, like opportunities for people that are, you know, in the mood to be in a more public space and in the mood to be in a more private space. And that, you know, yeah.
Great, thank you. And my second question will be communities that are in disadvantage are more affected by disabilities. What are your accessibility design plans?
I think that's something we still have to look into. We've wanted to make the elevator towards the middle, like central to the building, to provide access to everything. but we definitely want to stay away from creating any sort of spaces that that make it harder for, by creating steps and stuff like that. We definitely want to try to stay away from that. But yeah, that's something that we still have to kind of figure out as we dig deeper.
All of our doorknobs are going to be ADA accessible. We know that for sure.
Nice. No knobs.
Yeah. Tiny, even the small features like that, like intuitive doorknobs and yeah.
Yeah, I have one last question if we have time. Can you tell me more about how you decided on the number of dwelling units? At first glance, it seems like with the square footage of the building and it being 5 stories, the project should be able to fit in more apartments.
Yeah, so what we're really trying to do is provide housing for larger families. And so we're trying to really prioritize 3 and 4 bedroom units. I think we actually have like our largest, it's mostly 3 bedroom units, and then under that is 4 bedroom, and then 2 bedroom and 1 bedroom, because we really think, to provide affordable housing for larger families is kind of tough. And that's kind of something that's missing in the market. So we're kind of prioritizing that.
Great response. Thank you.
Thank you. Really good thought.
Yeah, that is all the time we have for Q&A. So thank you again for your great presentation.
Thank you so much.
All right. Next up, we have University of New Mexico. You are welcome to share your slides whenever you're ready. And yep, we're at
All right.
time, so go ahead.
Hello, we are the Engineers Without Borders chapter at the University of New Mexico in Albuquerque. And we're here to present what we've been working on for the last few months. A multifamily building complex that we're simply calling 1300 Lomas North, or 1300 Lomas. So I'm going to pass this over to my friend Grant, who is very much involved in the architecture, so that he can talk about how we chose our site.
Thanks, Heidi. So, located, you guys can hear me, right? Our site is located on a 4.7 acre lot, located in a very central part of Albuquerque. It is less than a mile away from UNM, Albuquerque High School, and the UNM Hospital, which is a great place for lots of rest and small housing. So I'd like to introduce our site a little bit more now.
We might have lost Grant. That's okay. I can pick this back up. So our site is divided off into 4 main buildings. We have 3 residential buildings and a grocery store. And it also makes a lot of space for multi-use ground level space. Things like a basketball court, a park, barbecue area. We've tried to make good use of the property, which is about 4 acres. And since Grant isn't here, I can. So to talk about our first building. Oh, yeah, I can hear you, Grant. You back?
Audio still sounds a bit choppy.
I'm sorry.
Yeah, that's fine. Okay, so building R is our mid-sized building. It's got a reasonable occupancy, about 140 people, and dwellings that mostly skew towards the 2-bedroom area. This kind of tunes it towards being optimal for maybe very small families, new couples, young adults, people with roommates. A feature of all of our buildings is they have these nice, enormous flat roofs for solar space, and this one in particular has 7,000 square feet. It also has a kind of terraced design, that allows for lots of multi-use sort of deck area that's elevated off the ground. This is exemplified a little bit more in building L, which kind of takes the deck area and applies more shading to it on most surfaces. So building L is also our largest building, and it features, it's the best example of things like our deck gardens, our multi-use space that's elevated. You can see we have partial shade from stuff like pergolas, but then we have full shade on most of the building. And for an example of how our buildings are divided up, we have 59 apartments in this building, and they're distributed mostly towards like the 1 to 3 bedroom range, which, yes, that optimizes it for like single people and new couples, but then it also can incorporate more small families. And both of those are like the highest demand of housing in this area, because we're trying to serve the university population, but we're also trying to serve like the people working at the hospital. Building F is our smallest building, and it skews a little bit more towards the 1 bedroom. We actually have quite a few studios on this one, but that's not shown in this graph. And this one, we didn't get as much of the shading on it, which admittedly is something that we need to work on, but it's there and it's doing its thing. So the last building is the grocery store, which is a fairly decent sized building. It's about regular for the grocery store, but we've subdivided it into a grocery store and a restaurant space to serve as sort of this community hub where people can go and they can have food access, but they can also come and, you know, eat together and meet and just enjoy it. It is important to note that there's suburbs around this area, so it's not just the people on the property that would be patronizing this, it's the whole area. And the nearest grocery store is like 2 miles away, so it's a little bit needed to kind of increase the walkability of all the nearby communities. An architectural component I want to point out are these colonnade facades, which you see a lot in like traditional Moroccan architecture, but they crop up all around the Mediterranean. And they function to shade exterior walls, which does a lot to keep heat off of the building. And you can see in this one that on the summer solstice, this southern wall only gets sun exposure for about an hour or 2 in the day. And even then it's like maybe a third of the wall. So it's fairly efficient at reducing the heating load on the building, or the cooling load on the building. They also become less effective at cooling in the winter when the sun is lower, which means that your building gets more heat when you need it and less heat when you don't need it. And to talk more about energy, let me introduce Chadi, who was in charge of the energy analysis component of this.
Thank you, Heidi. So considering this is a energy efficient housing project, a big concern was insulation. And what we've decided to go with is structural insulated panels using Icynene. Now, SIPs are a very good approach to this because it reduces the reliance on wooden studs, as they are much more structurally sound than other methods. Icynene is also 99% water, and it also lacks all of the dangerous chemicals that some of the insulating materials in its family contain. Besides that, we have a 63% kBT per foot square per year use, making this a very efficient project. Can you move on, Heidi? So as mentioned previously, we have ample roof space, giving us the opportunity to build a very large solar farm. This solar farm in particular will be 36,000 square feet, providing 150% of the site's energy demand. Most of this excess energy will be sold back to the grid, and this is an advantage to us as the local electricity company provides a 1-to-1 exchange ratio. Besides that, we're also focusing on the little things to make this a truly energy or carbon neutral housing project. By that, we're going to be using heat pumps instead of traditional ACs because they are much more efficient. We're also going to be encouraging our tenants to use Energy Star rated appliances. And we're also going to be using light pipes and tunnels instead of the traditional lighting to reduce the energy use. We're going to be using on-demand water heaters instead of the centralized ones. And a big portion of this housing project is that we included no hallways. This means less space to be maintained and clean. It also means less space to be heated, cooled, and lit, making this a truly net or carbon neutral project. Besides that, I'll be passing it over to my friend Astrid, who was involved with the interior and exterior design, and she will talk more about that.
Thanks, you're on mute, Astrid. And also we're just about at time, so give you another 30 seconds or so to wrap up.
All right, I just wanted to say that all the amenities are here for individual needs. And next slide, please. There's also the fact that we wanted to emphasize community and mental health through common walkway spaces and mixed apartment sizes throughout. Next slide, please. And for exercise, we have a basketball court and also a grocery store for the promotion of diet and exercise, and will be close by to many major institutions in UNM. Next slide, please. And we wanted to emphasize that there's a handful of projects we wanted to get to should this project continue, but well, we know that a major weakness is our accessibility, but here is some of the various ideas that we wanted to pull through for, and that's about it.
Thank you all for your presentation. I'll hand it over to our two jurors for Q&A.
Thank you. I like the exterior design. It's got elements of native Pueblo architectural style that would blend in with buildings in this area. And also the consideration of the grocery store to provide resources for the residents. For the envelope, you mentioned insulated panels. Have you considered any kind of mass wall for the envelope? It's common in New Mexico because of the passive heating and cooling it provides.
We did consider it, and we're currently considering it, but I'm gonna be honest, we did not consider it till the kind of end of the project. So if we do make it further in this competition, we will definitely incorporate it some way or another into the project.
Gotcha.
It was actually a bit of an internal debate.
Yeah.
Yeah, a little bit. We would have had to do a little bit of a redesign structurally to be able to put the thicker walls and everything necessary to have the kind of thermal mass elevated like that, which would have required a little bit of the redesign on the superstructure or the internal structure, which we could do.
Yeah, important things to consider though. You can't always just tack on like just so many layers of insulation and not consider the impact that it has on interior square footage.
Very interesting architectural design solutions that you have and the elements outside of the building. The design looks a little compact. You mentioned that you will use light pipes or tubes. What is the cost of this in the step of open a little more the building?
So we chose the compactness of the design. Sorry, one sec. We chose the compactness of the design for energy efficiency reasons. Not having internal hallways reduces a lot of the loads on our utilities, which we figured was favorable. Additionally, routing people around the outside gets them outside more, but it also lets us get people from different backgrounds who are having these different sized apartments, like walk past each other and everything. So these were like our top level decisions. The stuff like the light pipes and everything, we have actually been working on a design in our club specifically to have those incorporated along with the structure of a building. It's currently in progress, but we could use that to provide reasonably cheap lighting inside. Unfortunately, we haven't quite done the legwork on that yet. That would be something else for us to do in the next month.
Another question that go ahead, Sarah.
Go ahead, Liz. Okay. So the heat pump for the space heating, I think makes perfect sense. The tankless water heater, that one works well with gas, but assuming this is electric, something to keep in mind is that electrical costs can get really high with electric tankless water heaters. I think a heat pump system like what you're doing with the space heating would be worth considering using for water heating as well in this climate.
I appreciate that. One of the things that we had floated early on in the project was the idea of a solar water heater with a certain amount of water like stored in a tank on the top of the building. And
That
we
would also be a
decided,
great idea.
for simplicity's purpose, to just go with the solar, go for the passive cooling from the shade and everything, instead of trying to incorporate these active panels in. But that might be something that we decide to do in the future. Maybe if we took the hot water and instead of leaving it outside the building, we sunk it into the ground, like underneath the courtyard, or kept it more in the center of the building, and that could also keep it more properly insulated and reduce the effect on the architecture, I suppose.
Great. You have a great location to include a little more of passive strategies. So I would like to see a little more about this in the future. And another question about resiliency. What are the natural risks of the place and how the project will approach it?
So Albuquerque is it's a wonderful place to build, because for most natural pressures, the worst ones that you have to deal with really are the heat in the summer, which can get pretty crippling. The fact that it does freeze here in the winter. And we do have the occasional very light earthquake. You get that, you get the sun exposure, and you get the wind. All of these are not the worst to have to design around. We went for a solid sort of blocky design, pretty similar to a lot of what they do around here. You figure if people have been building in shapes like this for, centuries, then there has to be a reason behind that, and it's because it works for the local climate. So by informing our designs off of that, we can design for the same pressures without necessarily needing to go and break them down individually, I suppose.
All right, well, we are at time for Q&A. Thank you, New Mexico, so much for your presentation.
Thank you very much for having us.
Thank you so much.
All right, and
Thank you,
you're welcome. All right, that concludes the presentations for the semifinal competition. We will have the finalists announced at 2 p.m. Eastern time today. Pardon. I'll need to check on that. Finalists will be announced in the coming days. All right, thank you all so much for your presentations, and we will be in touch soon.
Thank you.
Thank you all so much.
Thank you. Have a nice day, everyone.